Minasan, konnichiwa, Zamurai Engineer desu. In this video, we are in part 3, module number 9, and let us continue with the discussion of this module with the second subtopic, which is about doors clear width. We are going to find out what are the requirements for the width of, for example, doors, passageway, stairs, so on. Okay, so it's very important topic, and again, let us start with the objective of the code, which states that the life safety code addresses specific requirements to minimize danger to life from fire, smoke, heat, and toxic gases. In doing so, it also provides mission continuity and property protection in both new construction and existing buildings. So we are part 3 with 3 subtopics. We are on the first module, number 9, elements of means of egress, under which we are now currently on the second subtopic, which is about width, doors, clear width, and allowable obstruction. So let us discuss what do we mean by width. In our code, particularly 7.2.1.2, door lift width, lift, meaning it looks like a leaf, diba? So just like a plant, just like a tree, there are leaves. Okay, so lift meaning a single unit of leaves is lift, singular. Okay, so lift width. So as you can see here, lift, a single lift, meaning we are talking about the part of the door which is moving, not the part of the door which is the hole, the opening. Okay, so meaning it is the cover, it is the part of the door which is the cover of the opening. Okay, so door lift width, but for other than a typical case where the door lift width is specified, and for example, there are specific subparagraph, the provisions of 7.2.1.2 address clear width of the door opening and egress, capacity width of the door opening. So as you can see in the picture, there is a minimum clear width requirement. So we have, for example, a wall here. There is a wall in this line. And on this wall, there is an opening for the door provision. So there is an opening here. So this opening, we have a door cover, and that is what we call here stated as door. Okay. So this is what we call door width. From this point to this point. This is the door width. This is the amount that will swing. This will swing into close and swing out into opening the door. Okay, swing out, close, swing, open. Okay, swing, close, swing, open. Okay, so 90 degrees, for example. Some doors will open more than 90 degrees or could be 180 degrees, right? But in drawings, in engineering drawings, we are taught to draw the doors as 90 degrees swinging. Okay, so 90 degrees minimum clear width. So this minimum clear width is actually, okay, if you can see here, is actually less than the door width. Okay, if you can see, it is less than the door width. The door width is from this point. The door width is from this point to this point. Okay, from this point. So there is what? There is what? Protrusion. There is a protrusion on both sides, and that is the minimum clear width. So minimum clear width means that this clear width is where our occupants of the building will use in order to get out of the building. Okay? So, okay? Okay? It is the space available for us. For example, there is a fire incident. So, there might be some people going out in this door simultaneously, about, for example, 2 or 3 persons going out at the same time. It is possible. It is possible because we have a minimum clear width opening like this one. Okay? It's possible. Not possible if one of the person is fat, okay, chubby, okay. So chubby, fat person, without disrespect for them, that is what the description of their body size, and that would involve what an effect on, for example, going in and out of an opening. So, for example, instead of 2 persons going out of the same opening at the same time, if there is a chubby person, it can only use one person. No? Can only access one person. It can only be used by one person if that person is fat. Okay, so that means an engineer must also think about those things, no, in his or her design. So how many percentage of the people are slim and fat? So, and use the average as your design assumption. Okay. So, okay. Next concept is this one. This one is what? Also minimum clear width with permitted obstruction. Okay. So in the first concept, we don't have permitted as obstruction. So what is permitted obstruction? As you can see here, the permitted obstruction is about 100 mm. Here, this is an obstruction. Okay, it will obstruct people going out of this opening. Okay, it will obstruct. For example, there are 2 persons that could in terms of size, could get out of the door at the same time. But because of obstruction, one of the person cannot get out at the same time with the other one. So because of this obstruction. So maximum, for example, is 100 mm. Maximum obstruction. Permitted obstruction. Right? Door width measurements might be used in calculating egress capacity. So it is computed. It is not assumed. It is not guess. It is not being guessed by the designer. It is being computed. So we have to calculate capacity for egress or in determining if a minimum door width requirement is met, depending on the purpose for which the door with measurement is used. The allowable encroachments on opening with the vary. Okay, so I think it is in terms of percentage. Okay, in terms of percentage. See the commentary in this specific subparagraph. 7.2.1.2.1.1 paragraph 6 and what paragraph 4. So as you can see, we have a picture of an exit door with clear width, okay, minimum clear width, and what height of the door, okay, which is 2.03 meters, okay, the height of the door, with hinge connection. So with hinge connection, so we have a frame. So the frame is not the one we are going to measure. Not from the frame. We are actually measuring what? from the least obstruction. Okay. So let us continue. Why the measurement of clear width is actually a design, a process, the method of measuring door width is required by several paragraphs in the code and for meeting minimum door opening. Clear width requirements specified like elsewhere in the code, not for determining the egress capacity of the door opening. Okay? Not for determining the egress capacity. Iba yung determination natin. Meron tayong design method para sa finding the egress capacity. Okay? Meron pang iba. So, ito yung width pa lang ng ano. For example, 7.2.1.2.3.2 requires a new door openings in means of egress to be not less than 810 mm. Okay? New door openings. Okay? 810 mm. Take note of that. You can memorize that. As a civil engineer, that is an important information. In clear width, based on need for an occupant traveling in a wheelchair, that is the width of a wheelchair, to be able to move the wheelchair through the door opening with allowance for the wheelchair user's arms in hand